Limit test review. We're going to start with numerical approach to limits. And so I'm going to use my graphing calculator and put 5x plus 4 into the y equals. And then I'm going to go to my table and plug in 1.9, 1.99, 1.999. So I can see what the limit as x goes to 2 of 5x plus 4 from the left appears to be. And looking at these numbers, it looks like it's getting very close to 14. Now I'm going to look at the limit as x goes to 2 from the right-hand side. Those numbers are also getting very close to 14. So I'm going to say the limit as x goes to 2 of 5x plus 4 is equal to 14. Notice I still needed to solve this by doing the numerical values, even though we now know how to do direct substitution, and it would be easy to get the 14 through direct substitution. Next, let's look at how to solve a limit graphically. So looking at our graph, the limit as x goes to negative 6 from the left is negative 2. From the right, it appears to be negative 2. Therefore, the limit is negative 2. But the function value is positive 2. So the limit and the function value do not have to be the same. Looking at negative 4 from the left and from the right, they both appear to be going to the same value of 3. Negative 1 from the positive side gives us negative infinity. Negative 1 from the left-hand side is negative infinity. Therefore, the limit as x goes to negative 1 is also negative infinity. But the function value does not exist there since we have an asymptote and the function never actually equals x equals negative 1. So look at our infinity. As x goes to negative infinity, my function graph keeps going up, so it's infinity. And as my x gets extremely large, it's approaching that horizontal asymptote of 1. A problem you might see on the exam is to solve limits using the properties of limits. So in this example, I can use the property where I can factor out the constant. So that's negative 1 times the limit as x goes to c of g of x. And then we can see from the given information that limit is equal to 8. So my answer is simply negative 2 times 16. Negative 2 times 8, which is 16. For b, I'm going to use the sum rule for limits, and I'm going to rewrite this as a limit as x goes to c of f of x plus the limit as x goes to c of g of x. Then again, use the given information to substitute in a value of 4 plus 8. Gives us a total of 12. Okay, for part C, I'm going to use my division rule. And that's going to become the limit as x goes to c of f of x divided by the limit as x goes to c of g of x. Substitute in the given information, that is 4 divided by 8, or 1/2. Finally, I'm going to use my radical rule, and I'm going to put the limit inside the radical, so limit as x goes to c of f of x, and then I'm going to square root that answer. So that becomes the square root of 4, which is simply 2. Then we're going to look at some algebraic ways of solving limits. So always start with direct substitution. In this example, I tried direct substitution, I get the undeterminate form. So that means I need to do some algebra simplifying. So let's start by factoring out a GCF. This allows us to cancel out x squared over x squared to give us the limit as x approaches 2 of 5x plus 8 over 3x squared minus 16. And then now that I cancel something out, I'm going to try direct substitution again and see if I can work out this problem. So in place of every x, I plug in a 0. Simplifying the problem down, I end up with 8 over negative 16, which is simply negative 1/2. In problem number 2, I also start by substituting 5 in place of every x to see if I can do direct substitution. In this case, it does not work because I do end up with 0 on the top, and 5 minus 5 is also 0. So it's an undeterminate form, and I need to simplify this. So I'm going to start by fixing this compound fraction by subtracting the two fractions on the top and getting a common denominator of 4 times x plus 3. Therefore, now I have 8 minus x minus 3 when I distribute the negative over 4 times x plus 3 times x minus 5 if I flip and multiply that bottom fraction. Combining like terms, I end up with negative x plus 5 over 4 times x plus 3 times x minus 5. Factoring out the negative from the top, I now can cancel out the problem factor of x minus 5, leaving the limit as x approaches 5 of negative 1 divided by 4 times x plus 3. So I'm going to go back to direct substitution, plugging in 5 in place of every x, simplifying down, and I end up with negative 1 over 32. So the answer is negative 1 over 32. Let's try some more algebraic limits. As always, I start with direct substitution, try to plug in 3 in place of every x. That's square root of 9 minus 3, which is 0, over 0. So this time I have a radicals and a binomial on the top, so I'm going to try the rationalizing technique. And that means I need to multiply the top and bottom by the conjugate, which would be the square root of x plus 6 plus 3. Once I multiply by the conjugate, I now need to simplify the numerator, and hopefully I'll be able to cancel out that problem term of x minus 3. After simplifying, I notice I have the limit as x goes to 3 of x minus 3 over x minus 3 times my conjugate, which is the square root of x plus 6 plus 3. So I can cancel out the x minus 3's and simply have the fraction 1 over the square root of x plus 6 plus 3. Now that I cancel something out, I'm going to go back and try direct substitution and see if this will work this time. So replacing every x with 3, I end up with 1 over 3 plus 3, or 1/6. All right, let's review some trig functions. So limit as theta goes to pi over 2 of theta tangent theta. As always, I'm going to try direct substitution before I do anything else. So replacing theta with pi over 4, I get pi over 4 times tangent of pi over 4. Well, the tangent of pi over 4 is 1. So this is just simply pi over 4. And it's an example where direct substitution does work in the problem. Let's do another trig function. Okay, this time when I plug in pi over 2, I end up with 0 over 0. So direct substitution does not work. So I need to use some of my properties, my trig identities, to simplify this down. So one thing screams at me, I have cosine squared. So I'm going to replace that with 1 minus sine squared theta over 1 minus sine of theta. Then I have the difference of squares on top, so let's factor that. And that should give us 1 minus sine of theta times 1 plus sine of theta. And conveniently, I can cancel out the 1 minus sine of theta to leave us with the limit of theta approaches pi over 2 of 1 plus sine of theta. Now that I've canceled something out, I'm going to try direct substitution again. So that's going to be 1 plus sine of pi over 2. I know the sine of pi over 2 is 1, so my answer is 2. All right, in this trig function, we're going to use that identity sine of x over x equals 1. But it's not quite there, so I need to multiply this fraction by 1, and we'll make 1 3 over 3. Rewriting this so that I have the form I want, I have the limit as t goes to 0, a 3 times sine of 3t over t. Over 3t, sorry. And then sine of 3t over 3 times 3. I can factor out that 3. And then I can use my identity to know that that limit is equal to 1. So my answer is 3. The last type of problem that will be on the quiz is the squeeze theorem. Now this can show up in many different ways. So the first one, let's look at the limit as x closest 0 of cosine of x squared times cosine of 1 over x squared. So I know the cosine function oscillates between -1 and 1, and I know the cosine of 1 over x squared also oscillates between -1 and 1. So I'm going to start with that as my inequality. Then to make the middle look like what's inside the limit here, I need to multiply everything by x squared. Now to find the limit, I'm going to take the limit of the left, the limit of the middle, and the limit of the right as x goes to 0. The limits on the limit as x goes to 0, negative x squared and positive x squared can easily be solved by direct substitution. So I replace every x with 0 and simplify, and I end up with 0. Since it's squeezed between 0 and 0, I know the limit as x approaches 0 of x squared times cosine of 1 over x squared must also equal 0. Okay, in our second squeeze theorem problem, we're given an inequality of 2x minus 5 is less than or equal to f of x, which is less than or equal to x squared minus x minus 3. And we want to find the limit as x goes to 2 of f of x. So all I do is simply take the limit of the left, the middle, and the right-hand term of this equation. So the limit as x goes to 2 of 2x minus 5 less than or equal to limit x goes to 2 of f of x, which is less than or equal to limit x goes to 2 of x squared minus x minus 3. I can solve this one by direct substitution. And the limit x goes to 2 of x squared minus x minus 3 can also be solved by direct substitution. Simplifying that down, I get a -1 on the left of this inequality. Also a -1 on the right of this inequality. So my conclusion is that the limit as x goes to 2 of f of x must equal -1 given the squeeze theorem or sandwich theorem.